It's really just a different way of approaching a problem. So, rather than drawing geometry as points and lines, we define parameters and relationships that define the way the geometry is built. And by doing it this way, we can modify the parameters and the geometry will change automatically. We're then free to operate on these parameters and undertake so-called computational design. So we can explore multiple design options faster and apply algorithms to find optimal solutions. Now, as you say, parametric and computational design have their roots in complex geometry, but its application has really started to spread in the industry. We see it being used, for example, in areas like spatial planning, master planning, and across structural design. I think my thoughts are the real value is realized when we apply this concept to our everyday work and our everyday tasks. So, for example, in our business, I've seen it used across a real broad range of activities, from the design of crane ties, which is quite a simple exercise, through to design of high-rise megaframes. The range of applications, it's almost endless. Yeah, the capex costs are rather surprisingly low. The software required is inexpensive, and it typically works with core tools that we already have, such as Revit. The biggest cost is accepting that there's an inevitable period of time where staff have to figure out how to apply these tools effectively on their everyday projects. It doesn't happen overnight, but if you can ride that phase out, the momentum can build quite quickly, and the rewards can be quite rapid on a project-by-project basis. For ourselves, we've approached it at grassroots level as a business, and we've more than recouped our investment in under 1 year. And this isn't applying it on particularly iconic projects, it's really just embedding the tools into our everyday work. When you give these tools and you put them into the hands of engineers, they're able to apply them on almost anything. It's almost like in the same way you would pull out a spreadsheet to solve an engineering problem. Nowadays they're turning to Rhino and Grasshopper or Dynamo. So they're applying it to everything. They're applying it to, as I said, simple activities like the design of crane ties. It's very well suited to the design of trusses, optimizing beams and beam spacing, right the way through to development of concept designs of load paths, an example I mentioned earlier, like high-rise megaframes. So a very, very broad range, but all offering value.